Okay, we're back. We're gonna do some few fixes for episode 5, like const correctness, unless I did that in off-camera change, which would be weird. And then we're gonna start implementing the leapfrog integrator. Okay, so first of all, nvim, what is this? Include slash particle.hpp, yeah. Yep, I think I didn't screw that up good. Did I do const correctness? No, I did not. Okay. Did it yank? I'm not sure. Anyway. Yeah, it did. Okay, it did yank. Okay, good. I'm just gonna. And now we're gonna have now we're just gonna mark this as const. Okay, I think that's done now. And now, here now, just since we can't do multiple lines, I'm just gonna. Not an expert in Vim here. I'm just gonna. The most simple method. No, not that far down. Why? Paste. And throw in some consts. Remember, it just is an int. If you need a signed int for some reason, you could always just treat it as an int, as a signed int in your extension. Okay, good. Okay, good. That's fixed. I should probably commit this. So I'm just gonna do that. What should the commit name be? Oh, I didn't even fix const correctness. I forgot to mark it as const. 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 No, not this here. Not here. I have to go down to this area. Const. 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 And is there anywhere else that I need to do anything? No, should be. WQ. Now I can fix that, which is much better. git commit am fixed const correctness. And I'm just gonna push in the same line. Okay, cool. This it works now. Surely building it's going to be. Is it what the build file again? Build.sh. Okay. Yep. And good. As a tangent, I know it does not show your password for safety reasons, but at least show like empty characters so I know how many I typed. But anyways. Yeah, did I even fix this? Does sh even build with sudo permissions? I'm gonna have to check. No, it does not. Okay. I'm gonna mark this as sudo. And now I think we're mostly done here. I think I'm gonna add a few callbacks for now. I'll just use standard functional. I mean, those are like one-off things, and those aren't hot loops. It's just once every time step. So standard functional should be good to do this job. Not standard functional. Standard function. Functional is the headers. Nvim. What do we do here? Nvim include slash simulation.hpp. Okay, I think we do include just functional here. And I'm gonna have a few callbacks, just simple. I'm just gonna have a standard function. And what should it take again? Should I Google standard function? Yeah, I'm gonna Google that. Functional, okay, yeah. Expected. Not sure why this thing is not doing anything though. Yeah, I'm just gonna have basically two conditions here for simplicity. Okay, now rather than having to try hard code anything, I'm actually gonna create an enum for this job. Enum class Yeah, actually I might just put it in here. Enum class status, and I'm going to explicitly say uint at. Not sure why it says it's an interface, but okay. And then you have okay and term. Okay, I'm just gonna set this equal to 0. So now we'll say it's gonna be standard function what's this gonna be a status given a simulation reference, yeah. Heartbeat. And I think we're good. As far as that's the only callback I'll implement. Function pointers are faster, but like these are only being called like once per time step, which I know can happen like a million times, but the internal force calculations can occur like 1,000 times more than that. It should be fine. Okay, so now wait, I have a genius idea here. Why are these just sitting here wasting memory when I can just literally make it like it's a knockoff variant and in the form of a union. Union. Unnamed union. Why did I forget the semicolon? Undo. Does R redo? No, it does not. All that did was for some reason insert another one. Also, I hate that it doesn't auto format, but I'm just gonna, my config doesn't auto format. I'm just gonna pretend. Okay, now that that's done beautifully, looks like we're done with that busy work, and now we're gonna begin work on the integrator. src slash, wait, did I include it? src slash I'm gonna ls src. I don't remember what's in there. Particle.cpp and simulation.cpp. Okay. Particle.cpp is trivial. These two are already done. So, I'm gonna create a new file for this. nvim src slash leapfrog.cpp. Hash include. Sorry for the minor microwave disturbance. Include. What do we need here again? Include. Integrator.hpp, I think so. Namespace FNB. FNB. It's so good. FNB, and what is this gonna be again? Okay. Void leapfrog step. Particle store. Particles and double DT. Yeah, how is NeoVim not smart enough to figure out that my tab spacing is 2 spaces and not 4? Anyways. Double DT. Yeah, so leapfrog is just, if you remember, it's just the drift for half a time step, kick the acceleration for the full time step, and then kick the acceleration, and then my brain is not braining. and then doing a half step drift again. Very easy. This is gonna be easy. I'm just gonna do a first non-optimized method here. I'm just gonna do like, I think it's gonna be very trivial to do this. Oh yeah, I forgot that I have another one. I'm gonna have to edit. I'm gonna have to leave this for now. Q, and now in nvim include slash integrator.hpp. Store particles. Particle store. Particles test. Do a very similar thing. In fact, this is probably literally going to be identical across files. I'm just going to YY P DD P. Right, it didn't copy, bro. What the why? It's DD. No, it didn't copy. Why? No, that was useless. But anyways. Come on, if you're not gonna copy, just... I'm gonna copy you directly. Why? You can't deny that, can you? P. 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 I just realized saying P like that just sounds concerning, but I can't do anything about that. Ah, come on, it only existed for one, bro. I mean, fine, do I have to... V, come on, you're not yanking properly, NeoVib. And then I immediately lost that. Why? What is happening? What did NeoVim do? Okay, well, at least now that works. WQ, and now we're gonna go back to leapfrog.cpp. Add this in. Particles test and double DT. Okay, cool. We are now completed. Almost. We're fully completed with this. Now we finally have to do actual logic. So this is probably the most trivial one. Yeah, I'm first just gonna write down the core logic and then OMP it later. I'm not using actual C++ multi-threading. First of all, that's C++ 20. And also, it's harder to write. I think you know why C++ 20 is a bad thing in this situation. Particles store particles, particles store particles test. What do? Yeah, I think we just loop through each particle of particles, and then in each we just do it in particles test. Yeah, because test particles don't actually do gravity, do they? Yeah, they don't. Okay, so I'm just going to for size t I equals 0, I is less than particles dot n plus plus I You have to perform a zeroing step first. Wait a second, I'm just gonna put an empty comment here. It just doesn't do anything weird. Remember, this is just an n operation, the zeroing. The inner force loop, that's an n by n operation, or sorry, n squared operation as it's more commonly called. So that is the thing we have to optimize this out of. But I will OMP that if I want to. Yeah, okay, so now particles dot n. In fact, I'm so tired of just typing, and I'm just gonna do const size t n equals particles dot n. And const size t and test equals particles test dot n. N plus plus I and here we're just gonna do very trivial stuff. Particles dot, not positions, velocities index I plus equals that's equals 0 0 0. similar thing for acceleration. And I think that's clearing it. What's the diagnostic? N. Bro, it's a constant. Not sure how it's like an invalid case style, but okay. So I honestly don't care too much about that. Yeah, I forgot there are like 3 different methods of implementing gravity. Yeah. Okay, I'm just gonna finish up the zeroing code here, and I'm going to implement gravity. Yeah, this is gonna be fun, isn't it? Velocities, accelerations, yeah, I think that's it. For now, unless that there are no errors there, but should I explicitly put like 0 dots there? I probably should. I'm gonna do that right now. 0 dot, 0 dot. Right to it. And vim. Include / integer.hpp. Well, I'm just gonna make sorry for the minor roadings, Dorian sounds. Enum class, what should I call it? Gravity method. Amazing name. And it should store, I'm just gonna call it basic. So far just gonna only have one. Basic. It's going to store basic. Just in case, you're probably gonna have more in the future. But let's just go for the simplest method for now, and then we're gonna add a few more complicated methods to come with leapfrog and then WH fast. And these are much harder: WH fast, IES 15, and Mercurius. Method. Alright, yeah, this has to be public, I forgot. Gravity method. Gravity. Which equals gravity method basic. Oh yeah, and it's still gonna have DT. It's gonna have a DT, not DT, sorry, epsilon parameter too. I don't think there's any more necessary. Ln equals 1 e to the minus 12. And I forgot to just set it to unit T2. WQ. Now you have to also create an include slash called gravity.hpp. Sorry for the minor sound effects in the background. If def gravity HPP define gravity HPP and if define gravity HPP, and I thought it was if ndef. Just screwing up. Yeah, I think I screwed up this header guard. It's if indef, not if def. Struct, and now what's the struct name gonna be? Wait, no, not struct name. This is it's normal. We're just gonna have to do calc Excel. Namespace FNB. Namespace Excel. And then you have void Jacobi, for example. And now I'm just gonna have particle store particles. and particles test. I think is this it for calculating acceleration? Is this it? I'm gonna add if necessary. I'm gonna rename this to basic. I'm gonna delete that actually. I don't think we need that right now. Int WQ. nvim src slash last excel dot cpp hashtag include gravity.hpp namespace FNB the namespace. I mean, it generated some weird reference things. I'm gonna switch that out like so. And now each of this is just going to end up, doing a one-on-one computation. It's not even going to be fancy. It's just a basic n by n loop. So. N is equal to size t and test equals particles test dot n. Sorry for the minor banging in the background. And now we're just gonna end up be just a simple loop now. For size t I equals 0. I is less than n plus I. for size t j equals 0, j equal to I, j is less than n, plus j, now we just do the good old method of particles dot compute the cube root 3 times. Square it 3 times, so I'm just going to do in var 3. Double in var 3 is equal to 1 divided by what is it doing that? Double mu is, bro, what kind of, is it not having a good day, bro? Double mu is equal to, what is double mu equal to? Double R is equal to particles oppositions I'm gonna accident that so much, I'm just gonna make it another reference. It's not a standard vector. You saw it near the beginning. It's not a standard vector. I'm just gonna do an autoreference. Positions is equal to particles dot positions auto velocities equals particles dot positions not dot velocities accelerations I think that's it for those, and now I'm just gonna make an exact replica of this but for test. Auto positions test is equal to particles test dot positions velocities test is equal to particles test dot velocities accelerations test is equal to autocomplete is kind of annoying. I'm just gonna positions index j dot dist, not vector other though. Positions index I. R times R times R times R. And I'm confused with the order here. Is it A minus B or B minus A? The order is going to be a problem. Because if I flip it, you end up opposite gravity. Opposite gravity is not a thing. I'm just going to call it scalar is equal to yes, probably so we get auto muse is equal to particles dot muse. Auto muse test is equal to test dot muse. I think that's it now. Beautiful. Muse index I divided by no 1, and this is since it's a double, it's still gonna be in for 3. Okay, this is gonna do it on both sides. Okay, now what's the order? We needed to point towards that, so going to have to just dr I'm gonna call it dp for delta position, and it's going to be get positions index I minus positions index j. I should probably map this out on Clacky. I'm not gonna copy off rebound. No, I don't want to open that now. Okay, so I have a point here, which let's say you have a point here and a point here. We would like it for this point to go in this direction and our point P to go in this direction. Nice. Okay, so let's say this is a 3, 2. Yeah, I'm only gonna do 2 coordinates here. The point should still stand. 4, 6, say. This it's gonna be -1, 4, which, yeah, that's actually accurate. It's in the correct direction. Therefore, we do in the opposite direction, that's gonna be 1, -4. Okay, yeah, I think I figured out the logic. If this is point I and this point j, it's gonna be index I minus index j. Okay. Index I, index minus j for j, and index j minus index I for I. Okay, that finally my brain is actually braining. And now I can do accelerations index j equals, it's not plus equals, it's just a straight up equals. At least I think it's a straight up equals. Equals dp times mu's index I divided by inverse 3. I still don't know why just now suddenly wanting to do index I equals negative dp times mu's index I times inverse 3. And this would be mu's index j. Surely it didn't flip this. So why did I put in as a double? It's a vex 3. Wow, that's a lot of warnings. And then for size t, j equal, now for the test one, so j is less than and test plus j vex 3 dp is equal to positions index I minus positions test index j. Double R is equal to Why'd I do this when I can just dp.mag? Double invar3. Yeah, actually the texting is really nice. I can just copy in variables decently well. Equal to, let's just equal to makes points. 1 dot divided by r times r times r. And now accelerations test is equal to test index j. A copy assignment should really not be allowed. Because that's way too accidental to just be able to randomly change the whole thing. But anyways, I'm gonna have to fix that eventually if it's not gonna cause any issues. Is equal to dp times use index I times invar3. And this is not going to go backwards because these are test particles. They don't affect anything. Okay, now that this is, it looks done. It's not throwing any errors. That's good. In fact, mu's probably don't even matter for test particles. And in force calculations, we probably don't need these either, so. Invalid case style. Oh, come on, I thought these were constants. I still don't know why it's doing it for n. I know it does that for n test, but why n? Random sound effect, something fell, anyway. WQ. I'm gonna hope and pray there are no linker errors. Wait, I'm not even done with that one. This is zeroing step. So we did a zeroing step, and now we're gonna do the first drift. So now I can just shorten this to n. And particles positions index I. Yeah, so I do need to update copy assignment to make that private because I don't want to accidentally do that. Particles positions index I plus equals what exactly? Oh yeah, dt, the velocity times dt divided by 2. Yeah, I'm not gonna micro optimize this. I'm just gonna do this calmly. for size t I equals 0, I is less than n test plus I. Particles dot test dot positions I'm only gonna zero the accelerations here. The positions index I plus equals E. I'm gonna have to shorten these again. Great. Should probably make a macro for this. That's what macros should be used for, but particles positions equals particles dot positions. Auto velocities equals particles dot velocities. Auto accelerations equals particles dot accelerations. Gonna make some, and for the test ones, auto positions test equals particles test dot positions. Auto velocities test equals particles test dot velocities. And auto accelerations test equals particles test dot accelerations. So now I can shorten this somewhat. Now I just have positions test. Again, next. 4. Or size t I equals 0. I is less than n plus I. Now here we're just gonna Excel basic. You're just gonna pass in particles and particles test. Next up, velocities. Velocities index I plus equals accelerations index I times dt for size t I equals 0. I will stand fantastic. I'm just duplicating these for 2. And this one has test prefixed, so times dt. Beautiful. Now we're just gonna have to. Now I'm gonna yank these 2 lines. And this whole thing is very parallelizable now. I'm just gonna. All these single statement for loops are. Parallel for. Yeah, I forgot DD also tends things to yank for some reason. He hadn't. I mean, I guess it makes sense, but. And I think I can DD this final line. Okay, so now all of this linear stuff is done now, I think unless I screwed something, unless I royally screwed something up, I think I'm good. Yeah, this is the most trivial way to do this. It's just gonna rely on pragmas. I'm gonna check simulation.cpp to see if I implemented that. Nope, no I did not. Well, that's gonna be for next episode. Yeah, these should be usable by itself. These things should be usable by each module should be usable by itself very well. So for my test code here, I'm just going to go into what is in here? LS unit test. Okay. See what's in LS unit tests. Test 1.cpp. nvim unit test slash leapfrog and leapfrog basic dot cpp. I forgot to update the Mason build file. God dang it. If for each and for each, some basic project here. Test 1, what should we call this one? Leapfrog basic. CD FreshNBody. And now I'm just gonna unit tests leapfrog basic dot. And that should be it for updating it. Oh my god, I forgot to update the Mason build file to include that. SRC slash. What's an SRC? Initializing multiple members of union. Bro. I'm gonna cut this from the video. Still doing it, I'm just off camera fixing. Off camera fixing right now. Okay, I fixed the ghost compilation issues. I just deleted the default constructor for Simulation 2. But there's actually a file I can just put in there. It's put in, there's already a thing there, so technically if the test files are in the executable, so in the build file, sorry. So I can just run it directly and see what it does. Okay, true. Okay, something is very weird. Let me just check what assert LE does. Less than or equal to. This to correct pause, and then Sarana. Man. Wow. This is confusing. Very. So I can run it directly. I'm just gonna do. I'm gonna include IO stream too while I'm at it. Nan. Now I didn't do very much. I'm just gonna make this slightly nicer here, so. Not sure where nan came from or divide by zero error. It can't be a divide by zero error because then that'd be infinity. Wait, is it a zero divided by zero error? Can't tell. Yeah, I'm just gonna stop the video for now. Fixing. Off camera fixing right now. Okay, I fixed the ghost compilation issues. I just deleted the default constructor for Simulation 2. But there's actually a file I can just put in there. It's put in, there's already a thing there, so technically if the test files are in the executable, so in the build file, sorry. So I can just run it directly and see what it does. Okay, true. Okay, something is very weird. Let me just check what assert LE does. Less than or equal to. This to correct pause, and then Sarana. Nan. Wow. This is confusing. Very. So I can run it directly. I'm just gonna do. I'm gonna include IO stream too while I'm at it. Nan. Well, that I didn't do very much. I'm just gonna make this slightly nicer here, so. not sure where nan came from or divide by zero error. It can't be a divide by zero error because then that'd be infinity. Wait, is it a zero divided by zero error? Can't tell. Yeah, I'm just gonna stop the video for now.